The combined gas law. It is as if we took the three gas laws that we've been studied so far and fused them together into a single expression. Previously, we've always kept one of the variables constant. Temperature was kept constant for Boyle's law, pressure was kept constant for Charles' law, and the volume of the gas was constant when we were talking about Gay-Lussac's law. The combined gas law allows us to track and calculate changes in the gas when more than one variable is altered. Let's see how it's done. At temperature of 300 kelvins and a pressure of 2 atmospheres, a gas has a volume of 240 milliliters. If the temperature is increased to 400 kelvins and the new pressure is 4 atmospheres, what is the new volume of the gas? So in these problems, two variables changed. The temperature increased and the pressure also increased. What is the new volume of the gas at the new temperature and the new pressure? Here is my combined gas law formula. I will be solving for the new volume V2. So I will take time to isolate V2 and rewrite the formula. Now I only need to plug in the numbers. So my final answer will be that the new volume of the gas will be 160 milliliters. A gas takes up a volume of 17 liters, has a pressure of 2.3 atmospheres, and a temperature of 299 kelvins. If we raise the temperature to 350 kelvins and lower the pressure to 1.5 atmospheres, what is the new volume of the gas? Now, pause this video and solve this problem yourself. Then unpause this video and see if you have the same result as me. This expression over here is a result of cross multiplication of this equation. Now I'm isolating my unknown V2. Plugging the numbers, and we can see that the final volume will be equal to 30.5 liters. Here is an interesting problem. What is the volume of the gas at 2 atmospheres and 200 kelvins if its original volume was 300 liters and 0.25 atmospheres and 400 kelvins? So this problem sometimes confuses people because it is written sort of backwards. The final parameters of the gas are given at the beginning of the problem and the initials are listed at the end. So let's make sure we write our data correctly. So initial temperature is 400 kelvins, initial pressure is 0.25 atmospheres, and initial volume of this gas is 300 liters. And then we know that final temperature is 200 kelvins, final pressure is 2 atmospheres, while final volume is to be calculated. Now that we have all the data set up correctly, we can solve this problem with ease. New volume would be equal 18.8 liters. As always, the reference table will come to the rescue if you forget your formula of the combined gas law. It is right at the back of the reference table set, not far from the information on how to convert temperature from Celsius degrees into kelvins, which is a must-do for any calculations that involve gases. But what about Boyle's law and Charles' law and Gay-Lussac's law? Are their formulas in the reference table too? In a way, they are. All of them can be derived from the combined gas law. In each of three gas laws, one of the variables was held constant. A constant term is equal on both sides of the equation and drops out of the expression. For example, if pressure is held constant, then initial pressure will be equal to the final pressure. In an expression of the combined gas law, we will omit the pressure and we will end up with the formula identical to the Charles law. If temperature is held constant, then we will drop the temperature out of the equation of the combined gas law, and we will end up with having Boyle's law to our pleasure. If the pressure was held constant, then we'll drop pressure, and here we have a Charles law. And if volume was constant at the beginning and at the end of the experiment, then we will drop the volume out of the equation, and we will end up with the Gay-Lussac's gas law.